This is lesson 1.2, simplifying square roots within Unit 1 of Algebra 1. More specifically, we're going to be looking at Learning Target 1.2, and really just the first part of the learning target that we can simplify radicals. And radicals is just another word for square roots, but it also includes higher roots like cube roots and fourth roots and things you'll get into in Algebra 2. But for this class, we will only deal with square roots. And you've probably seen some of these back in 8th grade and worked with them before, but we're going to get a little more into it in this class and actually start doing some operations with them in the upcoming lessons. But again, for this lesson, we're just going to be focusing on the simplifying of square roots. So just as a review, let's look at what is a square root. So with a square root, we're really looking for a number that can multiply by itself to equal the number underneath the square root. It's kind of the opposite. It's the opposite of squaring a number, or the opposite of raising something to the second power. Raising to the second power. So we're trying to think of what number could we raise to the second power, or what number could we multiply by itself to equal the number underneath the square root. For example, if we did the square root of 36, we know that 6 times 6 is equal to 36. 6 times itself is equal to 36. So therefore, 6 is the square root of 36. Now, as you can imagine, there are, or as you know, you've seen in the past, there are multiple perfect squares. We call this the number 36 a perfect square because we can find the square root of that. There are quite a few perfect squares. You may know that 4 is a perfect square because 2 times 2 is 4. We can keep going up the list. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and we could keep that going as long as we wanted to. But those are known as perfect squares. But for as many perfect squares as there are a lot more numbers that are not perfect squares. We cannot find the square roots of those numbers. And that is kind of why we use this simplifying of square roots, that we can't find the exact number, or there's not an exact number that will multiply by itself to equal something like, let's say, 15, but we may be able to simplify it and make it a little easier to work with. So let's look at simplifying square roots. And our first example is the square root of 75. The first thing that we're going to do whenever we're simplifying a square root is we are going to look for its prime factors. So I want to think of numbers that will multiply to equal 75. I happen to know that 3 times 25 will equal 75. It's kind of like 3/4. And I know that 3 is a prime factor, or a prime number, so I cannot break it down any farther. But 25 I know is 5 times 5. And now 5 and 5, those do not have any factors. I can't divide them by anything. So those are both prime factors, and I'm done factoring my number. So the square root of 75 is equal to the square root of 3 times 5 times 5 times all of its factors, prime factors. Well, with square roots, we're really looking for a number times itself to equal the bigger number. So when we're simplifying square roots, we want to find numbers being multiplied by themselves. Here I have a 5 times a 5. So I can actually factor that out, or bring that out of the square root to the outside, and we'll be able to use that whenever we're doing other operations in the future. So the simplified form of the square root of 75 is bringing that 5 to the outside. The 3 cannot be brought out because it's by itself. There's no other 3 there. So we have to leave the square root of 3 and we say that this is 5 square roots of 3, and this is the most simple, or the simplified version. Let's try another example, or a couple more. So we have the square root of 108. An interesting divisibility trick. You guys probably definitely know that you can divide that by 2, and that's fine. There's nothing wrong with that. But an interesting trick is I know that if I add up all the numbers in 108, 1 plus 0 plus 8, and that equals 9, 9 can be divided by 3, which means that 108 can be divided by 3. And that's just an interesting little trick. When we divide 108 by 3, we end up with 36. And again, you can factor this however you want to. 3 is a prime factor, so I can circle it. I can divide 36 into 6 times 6. Now, you could keep this going farther if you want to. You could divide the 6 into 3 times 2 and 3 times 2. I'm not going to do that because once you see that you have a pair of numbers, you can stop it there. So I can say that this is 3 times 6 times 6. And again, the square root, we're looking for something times itself, and I already see that I have 6 times 6. That's what I'm going to bring to the outside of my square root. So I have 6 square roots of 3. If you didn't notice that, you would have ended up with 3 times 3 times 2. You would have that 3 times 2 for the first square root, and another 3 times 2, for the first 6, and another 3 times 2 for the second 6. Again, we're still looking for pairs of numbers, and in this case we would have had a pair of 3s. And the one that's a little harder to see is we would have also had a pair of 2s. So if you happen to notice that, then we would bring both of those to the outside, and that would be the 3 times the 2 on the outside, and you still have this 3 left on the inside. So when we simplify 3 times 2, that is 6 square roots of 3. You still get the same answer. So it does not matter which way you do it, you still come up with the same answer. One more example, the square root of 78. So when we break that down, it's an even number. I already know that that's going to divide by 2. So I'm not going to put too much work into it. When I divide that by 2, I get 39. 2 is a prime number. 39 might look prime, but we can actually divide it by 3. And 3 and 13. Both of those are prime numbers. So I have finished my factoring, and I end up with 2 times 3 times 13. Those are all prime numbers. However, notice we do not have any pairs. There's no number being multiplied by itself inside this square root. So in this case, we say that this square root cannot be simplified, and we leave it exactly how we started, the square root of 78. We don't have to change it at all. The last example on your page, sometimes you will see this number out on the outside, which is kind of looks like it's already been simplified, but we need to check and make sure that there's nothing else that we can do. So we're going to simplify it just like normal, and we're going to look for factors of 12. I know that 3 times 4 is 12. You could have also used 6 times 2, and you'll come up with the same answer. 3 is a prime number. 4 can be divided into 2 times 2. And you may notice there's our pair that we want. So now I'm going to leave the 4 that's on the outside. So we have 4 square root of 3 times 2 times 2. And this is the pair that we want that we're going to bring to the outside. We leave the 4 on the outside. We're going to multiply it times the 2 that we're bringing to the outside. and we leave the 3 on the inside of the square root. So our final simplified answer would be 4 times 2 is 8, square roots of 3. And that is our simplified square root. So on the back side of your notes, just to wrap it up, in order to simplify square roots, here are our steps. The first thing is that we are going to factor the number under the square root into its prime factors. Prime factors. Or, as we noticed with the square root of 108, once you find pairs, or a pair of numbers, you can stop your factoring at that point. Our second step, and this is the big one, is we want to identify pairs of prime factors. And then we're going to remove the pairs from the square root. Remember to only use one of the pairs. So what I mean by that is when we brought this 2 out of the square root, I did not write 4 times 2 times 2. We only used one of those 2's, only used one of the pairs. Same thing when we did the 6 here. I did not write 2 6's on the outside. Okay, so make sure you only use one of the pair. And then, if needed, just like in that last example, simplify the expression if you have to. If there's no more simplifying needed, then just leave it as your final answer. Please write down any questions that you may have. You have a notes section on the side of your notes as well to keep up with any work that you need to show. And bring those questions to class, and we will see you tomorrow. Thanks.